Hello everybody, today we're going to be starting with the measurement of physical quantities, and this is the first chapter in physics O levels for IGCSE as far as I know, and hopefully this video can help you understand the concept of the measurement of length and also the measurement of time. So without further ado, let's get right into it. So starting with the measurement of length right here, there are four instruments that you need to know about. Now, the first two instruments are the easiest ones to know, so I'm going to cover them both really quickly at first. So what we have first is the meter rule, right? So we have the meter rule. And the meter rule is essentially just a ruler, and we've all seen it in our life. Now, when we're talking about the meter rule or the measuring tape, which are the first two easy instruments that we need to know about, we need to know three things in general. What is the accuracy of the instrument? What is the total length of the instrument? And what does each little line represent in the instrument? So starting with the accuracy of a meter rule, the accuracy of a meter rule is up to 0.1 centimeters. Whoops, that is a horrible circle. It is up to 0.1 centimeters, or also known as 1 millimeter, because remember 0.1 centimeter is also 1 millimeter. The total length a meter rule can measure is 1 meter or 100 centimeters respectively, because 1 meter is 100 centimeters. And this is shown right in the name. A meter rule means it's measuring 1 meter. Similarly, the total length a half meter rule can measure is, as you can tell, half of a meter or 50 centimeters, right? Because it says a half meter rule. And lastly, what does each line in a meter rule represent? So each one of these big lines right here, right? The 1 and the 2. So each one of these big lines right here, right? The 1, the 2, or the 4 right here. Each one of these little lines represent 1 centimeter, okay? So this is 1 centimeter, 2 centimeter, 3, 4, 5, 6, and etc. And remember, since it's a meter rule, this is actually supposed to be 100 centimeters instead of 15 centimeters. And each of these little lines represent 1 millimeter, because 10 millimeters, 10 of these little lines make up 1 centimeter. Lastly, we need to know about what a parallax error is. And essentially, when you're measuring with the meter rule, you need to make sure that you're looking down vertically right here. You need to make sure that you're looking down vertically onto the meter rule in order to avoid parallax error. Now, what is a parallax error? Well, if you take a look right here, if we look at the ruler at an angle like this, the measurement we get is actually 3 centimeters. Now, that's simply not the case, because it is supposed to be exactly 3.2 centimeters, not 3 centimeters. Similarly, if we look at this angle right here, it measures up to 3.4 centimeters. Again, that is incorrect. And this incorrect measurement is known as parallax error. Now, when it comes to a measuring tape, which is the next instrument that we're going to look at, it is almost exactly the same as a meter rule. The accuracy of a measuring tape is again 0.1 centimeters or 1 millimeter, same as the meter rule. Similarly, same as the meter rule, each big line represents 1 centimeter, and each little line represents 1 millimeter. Okay, it's the exact same as the meter rule. The only difference is that the measuring tape does not measure only 1 meter, but it measures more. It measures more than 1 meter. For example, 100 meters. So a measuring tape can be used to, for example, measure the length of a field instead of just measuring 1 meter of an object, right? As for what a measuring tape looks like, I think you all have also seen what a measuring tape looks like. This is what a measuring tape looks like right here. These are various types of measuring tapes. And again, it has the same accuracy as a meter rule, as you can see. The only difference is that it's pretty flexible and very long in length. Anyways, now we're going to move on to the hard part, which is the vernier caliper and the micrometer screw gauge. Now, these two are the hardest instruments to work with because they're very complicated to understand. But don't worry, I'm going to try my best to explain them to you in this video. So starting with the vernier caliper right here, it may seem very complicated, but it's actually quite simple when you look at it in a different way. Now, for a vernier caliper, the top scale that you see here, the big scale, is called the main scale, okay? So the top scale is called the main scale. Now we're going to get to the vernier scale soon, but remember the main scale is essentially the same as the meter rule, it just measures centimeters. So this would be technically 10 millimeters, or also known as 1 centimeter. 1 centimeter, 2 centimeter, 3 centimeter, and etc. It just keeps going on. So essentially it's just a meter rule, and there's nothing different about it. And as you can see from this example right here, this point right here is 5 millimeters, and this point right here is 10, also known as 1 centimeter, right? I think you can get the grasp of that. Now make sure when you're measuring with the vernier caliper that the 0 is always pointing at the line you're measuring. Not this side of the scale, not the end, but the 0. That's very important if you want to get the accurate measurement. As for knowing the accuracy of a vernier caliper, it is 0.1 millimeters, okay? And again, you can see that I wrote here that the main scale is essentially similar to the meter rule, right? 1, 2, 3 centimeters respectively, and each line represents 1 millimeter. Now we can safely move on to the vernier scale. Now this is the part where most people get confused. So what is the vernier scale, right? Now just remember one thing, that each little line in the vernier scale represents 0.2 millimeters, okay? So each of these lines you see here, this, 0.2, 0.4, 0.5, 0.6, it just keeps going on like this until you reach 1 millimeter. So if I show you from a closer up right here, this point would mark 0.02 millimeters, right? And so on, this would be 0.04, 6, 8, and this would mark 0.10 millimeters. So the 1 in the vernier scale represents 0.10 millimeters. And similarly, this goes up to 10, which means this would become 1 millimeter. Now here's an example question of the vernier caliper. So what will the reading over here be? Now remember that the 0 is pointing slightly above the mark of 16 millimeters. As you can see, this is 10 millimeters, 1, 2, 3, 4, 5, 6. So it's just slightly above 16 millimeters. So now we look at the vernier scale and we see where the vernier scale lines up the best. Now as you can see, this line of the vernier scale lines up with the main scale perfectly right over here. Do you see this line right here? It lines up perfectly. And the reading we get here is exactly 2. So this means that in total it will be 16 millimeters, which we got from here, and 0.20 millimeters, which we got from here, from the vernier scale. And add them up together, we get 16.2 millimeters as the final answer. Let's take a look at another example. Right here we have another reading on the vernier scale, and we need to figure out what it is. So again, first look at the main scale. We have 10 millimeters right here, okay? And this will be 11, 12. As you can see, the 0 lines up exactly before it hits 13. It is not on 13, it is not after 13, it is right before 13. So this means the vernier scale, the measurement will be 12 point something. So now we look at the vernier scale, right? And what we see right here is where does it line up the best in the vernier scale? If you look around carefully, you'll see that this line right here, it lines up best, right? And what is this measurement right here that it lines up with the main scale best? If you look at this, this will mark 0.70 millimeters, okay? If you remember from what we talked about before, each of these big lines represents 0.10 millimeters. So this will represent 0.70 millimeters, right? Similarly, each little lines are 0.02 millimeters, so this will be 0.72 millimeters, this will be 0.74 millimeters, and finally we'll have 0.76 millimeters. And that will be the reading on the vernier scale, which we wrote right here, right? And so we just do the calculation, the 12 millimeters from the main scale, you add that to the 0.76 millimeters from the vernier scale, and we get the final answer, which I apologize for the big marking, but the final answer would be 12.76 millimeters. Now moving on to the last instrument of length, we have the micrometer screw gauge. Now the micrometer screw gauge is kind of similar to the vernier caliper, and I'll show you how. Now if we look closer right here, we can see that this is what a micrometer screw gauge looks like. I'll show you a zoomed out picture soon, but this scale right here, you can imagine this big scale right here to be the main scale of the micrometer screw gauge. We call this the barrel scale. Okay. Now for the micrometer screw gauge in the barrel scale, you notice that there's top lines and there's also bottom lines. Now don't get confused by this, it's quite simple actually. The top lines, each of the top lines at the top represent 1 millimeter. So this will be 1 millimeter right here, this will be 2 millimeter, 3, 4, 5 millimeter, 6, 7, 8, 9, and 10 millimeter, and so on. It just keeps going, right? So this mark right here, this line right here, represents 12 millimeter. Now these little lines at the bottom, I'll give a different color. These little lines at the bottom, each line represents 0.5 millimeter, so half a millimeter. So as you can see, these lines actually line up exactly in between each 1 millimeters if you check carefully. This means that each of these lines represents 0.5 millimeter, just to give that little bit of accuracy. It's also important to note that in a micrometer screw gauge, the edge always determines the reading. This means this edge of the barrel right here determines the reading, and we'll get more into detail in a further example. Now, as you can see from this small example right here, just to show these little lines that we talked about earlier, this line right here represents 11 millimeters, right? This is because this is 10 millimeters, right? This is 10 millimeters, and this is 11 millimeters. And as you know, these bottom lines each represent 0.5 millimeters, right? Now remember, the line before the edge always determines the reading in a micrometer screw gauge. And as you can see, the last line before the edge is actually a 0.5 millimeter mark, right? So this means the total reading is not 11 millimeters. Instead, it's 11 millimeters plus the 0.5 millimeters that we found right before the edge. And in total, you add it up and you get 11.5 millimeters. Now that you have understood the concept of the barrel scale, we can now move on to the thimble. Now this is the more accurate scale, just like what the vernier scale would be to the main scale in the vernier caliper, right? So each little line in the thimble measures 0.01 millimeters. And so you can tell that the accuracy of a micrometer screw gauge is exactly 0.01 millimeters, a little bit more accurate than the vernier caliper. So this line right here, what would this line right here measure? As you can tell, since this line is 35, the line before right here would measure 0.34 millimeters. So this line right here is 0.34 millimeters. The maximum a thimble can measure is 0.50 millimeters, and you need to keep that in mind because a thimble cannot measure more than that. It only measures up to 0.50 millimeters, right? So as you can see right here, this is 0.40 millimeters right here, and we're kind of approaching slowly to the end of the thimble. Now let's look at an example of a micrometer screw gauge question. So how do we measure this right here? Now it's quite simple. Remember, we need to measure from the edge, right? So the edge is very important in the measurement of a micrometer screw gauge. So remember the line before the edge right here, the final line before the edge, as you can see, is 12 millimeters. That is the final line before the edge. It is 12 millimeters, right? 10, 11, 12. So we know that's not 12.5 millimeters, it's not 11.5 millimeters, it's 12 millimeters. Now, after we figure out the measurement in the barrel scale, we can now look at the thimble. So what we have to do is kind of similar to the vernier caliper. We have to see what this middle line right here, you see this middle line right here that separates the top and the bottom? We need to make sure that the thimble, the measurement of the thimble lines up exactly with the middle. So where does it line up the best? It lines up the best right here. Do you see that this line right here almost lines up with the middle scale right here, with the middle line? And this line, as you can tell, this is 0.30 millimeters. 0.31, 32, 0.33 millimeters. This line right here represents 0.33 millimeters. The rest is quite simple. You just add the 12 millimeters we found from the barrel scale, and then we add the 0.33 millimeters we found from the thimble. We add them together and we got the final answer, which is 12.33 millimeters. The reading in this question is 12.33 millimeters. Let's take a look at another example. Now this is a different example, and you'll see why. You see, the line before the edge is not 11 millimeters, but as you can see, there's also a half millimeter mark right before the edge of the thimble. So this means the reading right here is not 11 millimeters, but it's rather 11.5 millimeters, or you can also write it as 11.50 millimeters. So remember, we work on this step by step. Once we figured out the barrel scale reading, which we have right here, which was 11.50 millimeters, we now look at the thimble. Now the reading at the thimble, as you can see, the line which lines up the best with the middle line right here is this line, right? It's this line. And this line right here reads, this is 0.20, this is 0.20 millimeters, 0.21, 0.22. The reading right here is 0.22 millimeters. Now remember, the barrel scale reading was 11.50. It was not 11 millimeters because of this half millimeter line. So it's 11.50 plus the 0.22 millimeters we found from the thimble. You add them together and we got the final answer to be 11.72 millimeters. And that's really it. Now sometimes we have this problem where we don't really know if a mark is ready or not, if a line is ready or not from the edge, because it's right at the edge and we don't know if it's ready or not, but it's showing, right? So how will we know if it's ready or not? The way we can figure out if a mark is ready or not is by looking at the thimble. Now remember, a new mark always starts at 0, okay? A new mark always starts at 0. The thimble measures the maximum of 0.50 millimeters, right? So once we pass the 0.50 millimeters, this would technically represent 0.50 millimeters, since this is 0.45 millimeters, right? So once we pass the 0.50 millimeters, we can pretty much say that this mark here counts, because this is a 0.50 millimeter mark, right? Or 0.5 millimeter mark. But it has not counted because actually the line, as you can see, let me just remove that. The line lines up with the middle line right here best at 0.47 millimeters, because this is 0.45. I know you can't see it, but this is 0.45 millimeters. So it lines up best at 0.47 millimeters. It's not 0.50 millimeters. That means it has not reached the half millimeter mark yet. So that's how you can tell that the mark is not actually ready. It's not ready. The reading here, the total reading here would be 11.47 millimeters. Now if we look at the final example where the mark is actually ready, how do we figure this out, right? So as you can see right here, the line is barely at the edge of the thimble. We don't know if it's ready or not. How do we know if it's ready? Well, first of all, look at the barrel scale. We know that the measurement right here is actually 11 millimeters, right? And now we look at the thimble. We see that the line is actually lining up with the middle line right here after 0. Now remember, the 0 represents 0.50 millimeters, right? So it's after the 0, right? So the reading essentially right here starts over. See, this is 0.05 millimeters, 0.010 millimeters, oh sorry, 0.10 millimeters, right? So the reading right here is actually 0.02 millimeters. So that's how we know that actually a new mark has started, since it passed the 0 mark. So that mark is actually ready. So we can count this mark in. That means the measurement will be now 11.52 millimeters, because this mark is ready, and now we're adding from 11.50, we're adding 0.02 millimeters, the measurement we got here, to the 11.50 we already got, since this mark is ready. And that's all you need to know about the micrometer screw gauge. Now if we move on to the measurement of time, it's actually quite simple. It's actually simpler than the measurement of length. And there's only 3 instruments that you need to know about. The first one we'll start off with is the stopwatch. And as we already know, it's just simply a digital stopwatch. And the accuracy of a stopwatch, you need to know the accuracy, is up to 0.01 seconds. So this right here will be 12.04 seconds, right? The reading right here is 12.04 seconds. I apologize for the very messy looking 4 right here. But the only other thing you need to know about the stopwatch is that when we're measuring the stopwatch, when you're actually measuring with the stopwatch, there's actually a time interval where the stopwatch needs to be started and it also needs to be stopped by hand. So when we're using a stopwatch, we're pressing the button to start the stopwatch, right? The countdown or the timer. And we're also pressing the button at the end when we're done using the stopwatch. Now, this obviously wastes a little bit of time from the actual accurate measurement. So this can induce an error called the human reaction time. This error is actually quite similar to the parallax error we talked about earlier, where the parallax error was obviously a visual error looking down. We need to make sure that we look vertically down onto the ruler. The human reaction time error is exactly what the word says. It is the human reaction time problem, where some people may have different reaction times than you, right? People have different reaction times. For example, an old person would have a different reaction time than, let's say, a young person, right? They'll have a longer reaction time. So for most people, the reaction time is actually 0.3 seconds. You don't really need to know this, but it's just a general knowledge right here. And for older people, it's much more. So we need to make sure that we do not account the reaction time into the actual reading we got from the stopwatch, because that can induce the human reaction time error, right? That can induce this error. So we need to make sure that we do not account for that error. So essentially, when we're using a stopwatch, we make sure to reduce the actual timing. So since the measurement right here is 12.04 seconds, we would probably take the measurement to be actually 12.01 seconds, right? Just in general. But make sure when the human reaction time is not mentioned, do not write 12.1 seconds. You actually write the measurement you see on the stopwatch. The second instrument that we're going to talk about is a typical watch that you see in everyday life. The accuracy of a watch is 1 minute or even 1 second. It can measure up to 1 minute or 1 second, right? Depending on the type of watch you get. And essentially it's just used in day-to-day life to measure the time. Then lastly, we have the pendulum clock. Now, the pendulum clock is a very old type of clock, and the accuracy of a pendulum clock is actually 1 second, exactly 1 second. And it can measure hours, minutes, and seconds. It's basically the same as the normal watch that we looked at earlier. Now, to end this video off, we're going to go through some conversion of units. And this is very important, especially in this topic, to make sure that we got the right unit conversion and we do not get the wrong answer. To begin off with the first unit conversion, we got length. Now, to work with length, to go from a kilometer to a meter, we need to multiply by 1,000, okay? And then, to go from a meter to a centimeter, we need to multiply by 100. And then lastly, to go from centimeter to millimeter, we need to multiply by 10. So it really just decreases by 10 as you go from kilometer to millimeter, right? The multiplication, I mean. And make sure when you're converting from millimeter to centimeter, you're dividing by a 10. Centimeter to meter, 100. Meter to kilometer, 1,000. There's really no easy way to get around the conversion of units. You just have to kind of memorize it by heart on how they work. So just take a look at this diagram and make sure you just completely memorize how the conversion works right here. And these are some examples that I wrote right here. For example, 5 kilometer, if you want to convert it to meter, it will be multiplied by 1,000, and so it would become 5,000 meter. Similarly, if you want to convert 5,000 meter to centimeter, you multiply by 100, you get 500,000 centimeters. And if you want to convert 500,000 centimeters to millimeter, you just multiply by 10 and you get 5 million millimeters. So this can also say that 5 kilometers is technically 5 million millimeters. Moving on to time works a little differently than other conversion units because it really varies on whether it's week, days, hours, minutes, or seconds, right? So if you want to convert from a week to days, you multiply by 7 because there are 7 days in a week, right? If you want to convert days to hours, you could multiply by 24 because there is 24 hours in a day. If you want to convert hours to minutes, you can multiply by 60 because there are 60 minutes in an hour. And similarly, if you want to convert minutes to seconds, you multiply by 60 because there's 60 seconds in a minute. And if you want to go backwards, where you go from seconds to minutes to hours to days to weeks, it's the same thing, but instead of multiplying, you divide. Again, you just have to memorize these by heart. There's no easy way around it. And these are some examples that I wrote for you right here, where 2 weeks you multiply by 7 to get 14 days. 14 days to hours would be multiplied by 224 to get 336 hours, and etc. Now we're working with the unit conversion of mass. Now mass is extremely simple. All you have to do to convert from, let's say, a ton to a kg is multiply by 1000. Similarly to kg to gram, you multiply 1000, gram to milligrams, multiply by 1000. Essentially, it's the same for every single conversion. You just have to multiply by 1000. And again, if you want to go from milligrams to grams to kilograms to tons, you just have to divide by 1000, 1000, and 1000. Pause the video to look at some examples that I wrote here, how 5 tons is actually 5000 kilograms, and etc. Volume is pretty much the exact same as mass, as you just have to multiply by 1000 to convert from one to another. But what you do have to memorize is where each of these units really stay. For example, we need to make sure that meter cubed comes before dm cubed, which also comes before cm cubed, right? So really, just take a good look at this graph right here. Pause the video and take a good look at this graph and try to memorize it by heart, where you have to just multiply by 1000 to go from left to right and divide by 1000 to go from right to left. And these are some examples right here that I wrote down for you. And the last and final unit conversion that I'm going to talk about is temperature. Now this will be handy when we deal with thermal physics, which I'll post videos on later, but essentially it's pretty simple. To convert from the unit of Kelvin to Celsius, we just have to add 273.15 to the value we get. So for example, 50 degrees Celsius is actually 323.15 degrees Kelvin. So if we had, let's say, 100 degrees Celsius, we just add 273.15 to it and we get the value of Kelvin. And similarly, we can, if you want to rearrange it to find out the Celsius from Kelvin, let's say we had 50 degrees Kelvin, we just subtract 273.15 from that value to get the value of Celsius. And that's really all you need to know about this topic. I hope this video helped, and I'll see you all in the next video. Bye-bye.